This video gives an introduction to creating numeric models in Leapfrog. We'll start by visualizing the numeric data, then create an initial numeric model, and finally make some simple edits to the model so it more accurately represents the data. For further details, have a look at the Leapfrog Fundamentals PDF attached to this session. We're going to create a numeric model representing the RQD data in this project. We'll start by dragging the RQD drilling into the scene to view it. The default color map assigned to the data is set using the values of the data. The color map can be edited by double-clicking on it in the scene list. In this case, I've edited the color map so that all high-quality rock with a value above 90 is going to be colored red, and all low-quality rock with the value below 50 will be colored blue. Changes made in this graph are updated dynamically in the scene. So if I move this lower curve point upwards, we can see that change reflected in the scene. Click Close to close the Color Maps window. Right-click on the Numeric Models folder and select New RBF Interpolant. There are a couple of options in the first window that we're going to change. Firstly, make sure the numeric values are set to RQD. The surface filter can be used to filter out data which lies outside the boundary of the model or a specified volume. We'll keep this on its default setting for now. Creating a composite of the drill holes has a few advantages. The sample spacing in these particular drill holes is 0.25 meters, which means there are over 180,000 individual data points in this dataset. Compositing lets us reduce the number of data points by averaging values over a specified length. This firstly reduces processing time, and secondly removes outliers in the data. In this case, compositing to a length of 10 meters gives us enough detail. In this model, the drill holes extend to a significant depth below the tunnel, so we don't need to worry about the end lengths. We'll change the boundary of the interpolant to match that of the existing geological model, and change the surface resolution to 10 to match the composite length. Click OK to create the numerical model. The processing time of the model depends on the speed of your computer as well as the resolution of the model. Once it's finished processing, clear the scene and drag the RQD model into the scene to view it. The default model created by Leapfrog is almost always incorrect. To make it represent the data more closely, we can change a few simple settings in the interpolant. To do this, double-click on the RQD interpolant in the project tree. The main changes we're going to make for this model are in the interpolant and the outputs tabs. For the interpolant, we're going to change the interpolant type to spheroidal, the base range to 200, and make sure the drift is set to constant. In the outputs tab, we're going to remove the default ISO values and add our own ISO values at values of 40, 50, 60, 70, 80 and 90. There are a number of additional changes we could make to the numerical model to make it more accurately reflect the data, but as this is an introductory training video, we'll make a basic model to demonstrate the process. Click OK and let the model reprocess. Now that the model's finished processing, we can drag it back into the scene to view it. By looking at our surfaces, we can see that the high quality rock seems to correlate with the QZP and the G&D intrusions. The next step is to create a combined model, combining the inside and outside model we made in the design session with the numeric model that we've made now. Right-click on the Combined Models folder and select New Combined Model. Tick the checkbox for the tunnel model, as well as for the RQD numeric model. Click OK, and then tick the checkbox for inside the tunnel model and the checkbox for all RQD values. Click OK and the combined model will process. When the combined model's finished processing, drag it into the scene to view it. We can see different volumes representing inside the tunnel combined with each rock quality, and we can check the actual volumes of each rock quality by clicking on the relevant area of the tunnel. So this area is a volume of just over 37,000 cubic units. It's inside the tunnel and it has a rock quality between 70 and 80. As this is an introductory video, we're not going to go into any further detail for creating numeric models. If you would like further detail, contact your local Leapfrog support office or have a look at the PDF described at the end of this video.